since 1989, I think. And that is the website. I want to make sure you see that website. If you get something that says svec.org, unfortunately, that's an imposter. And for now, and we hope to get it back. We're in litigation, and hopefully the judge will sign with us and we'll get it all back. But for now, be sure you use the svec-ca.org. If you get an email purporting to be from us, and it's from that old organization, just svec.org, that's not us. And just send it to one of us and we'll tell you all that. Okay. So what is it here? Well, originally it was intended to unite the engineering community. And I've had a couple conversations with a number of you where we've talked about in these times, especially post-COVID, and especially as all sorts of things have changed and are high tech, that it used to be the engineering professional organizations, and it still is for us, but the engineering community is enlarging itself with meetups and all sorts of things. So how do we adapt and change for that? But the idea was to form leadership alliances across the engineering societies, reach thousands of engineers, and outreach to the community. So originally, and we still try to, is communicate between societies, trying to cross-pollinate ideas, and then promote educational programs, which in particular we do with scholarships and have done for a couple of years again now. It also offers leadership and volunteer opportunities. I was again talking to one person here, and we were talking about what is the relevance of engineering societies today. And I'll say that I've been a Society of Women Engineers member for 52 years, since I was a college sophomore. I graduated from college in '74. And we're getting some feedback back. Okay, try this. So anyway, what for SVEC for me, the really benefit was, I think I'm going to turn the speaker off. So if that still works. Nope, still got it. Anyway. For me, Society of Women Engineers, I got involved and I was a leader. I was a president. I was a section representative. I was a treasurer. So it gave me those opportunities. And when I went into management and engineering, it allowed me to then, hey, I leveraged all that stuff. That's what engineering societies often used for new engineers, give them that opportunity to grow in. I mean, I was a senior director for quite a long time. That was my last final role before I retired. So that's what organizations provide. And we're trying to help them all connect. So we also reach out to young people. We're trying to inspire young people to go in engineering and computer science. That's certainly my goal and has been my goal since I retired in 2011. So education awards that Yannick is going to talk about a little bit. She's going to explain what some of those are, and assisting teachers and mentors with those. We want to inspire young people. We need more engineers to get involved as volunteers with many types of programs. I know I personally have volunteered for FIRST for 20 some years, a number of folks here. How many volunteer for FIRST at all? I know at least did, some others, Felicita. So it's a way to get involved with young people, to inspire them and so forth at all ages. The other thing we do that's been a big piece of SVEC from its beginning is we honor luminaries in the high-tech world. And we call this the Hall of Fame. So we induct Hall of Fame inductees every year, and we've got a whole cadre of them. Last year we inducted Dr. Ranjan Nag, and this year we've got a number that are, the judges are now going through the selection process. We'll be announcing it, I hope, by the end of the year. I don't know the exact schedule, but we'll have it out there and they'll be inducted at our February event, which is February 18th. So it's a way of recognizing engineering accomplishments that inspire people, and it brings attention to the engineering community as a whole. We have currently only 6 member organizations. This group, SVEC, has been much bigger. We'd like to get bigger again. So if you're in an organization, a professional engineering organization that isn't up there, and you're interested, we'd really like to talk to you. I talked to a gentleman from ASQC. I still think of it as ASQC because it was the first thing I ever joined back right out of college. But ASQ, we'd like to get SHIP, other organizations. So currently we have primary delegates and alternate delegates from 6 organizations. But if you are interested, let us know. We also have a leadership team. We have 9 people on the board of directors. I'm the president. Kim, I'll just have people stand. So Kim Parnell is the vice president, and Richard Schaefer, which I've seen, there he is back there. Secretary Elise is our treasurer. Glenn Friedman back there is one of the directors. Yannicka, she's here, I guess. She's been doing the food for us today. Yeah. And so, yes, thank you very much. So Dr. Schneider's going to talk a little bit. And then Michael Wright, who's back there managing our video and arena stuff, is a director. And then KRS Murthy right here. And then Liana Yee, I saw her there. She is back there. She was our president last year, so she's a member of the board as the past president. We also have standing committees with committee chairs. Those chairs are, for the most part, meeting pretty regularly and putting things together. We're going to talk about a couple of them today, which is education as well as the Engineers Week Gala, and I'll tell you a little bit on the Hall of Fame. We've also got a couple of ad hoc committees. One of them, the middle one, is very nascent at this point. We're trying to work with the Hall of Fame inductees to potentially put together some engineering leadership distinguished speaker series to see if that might be a way of bringing some of the prior inductees out and sponsoring something like that. So that's if you're interested in getting involved in getting that kind of thing, talk to Kim. And then unfortunately, we have a legal committee. We didn't think we had to have one, but we do have one. And Kim is the one who works with our lawyers on the civil litigation we're under. Okay, so the events for fiscal 25, the open house, thank you very much for coming. We've got education, scholarships, and Keeper of the Flame. Yannicka's going to talk on that in a minute. And we've got this Engineers Week banquet, February 18th, 2025. And it is, we think, the 30th or 40th, I'm trying to remember, some big ticket number that we've been doing these inductees, and we're planning on a Hall of Fame reception with invited guests. The keynote speaker is to be determined, and then we'll have inductee or inductees. We'll also give the education awards to high school students, undergraduate college students, graduate college students, and Keeper of the Flame, which are teachers in the K through 12 education arena that foster STEM. And then the new one we're adding in, we've got a woman, Dr. Catherine Fang, right? I get that right, Yannicka? She's professor at Carnegie Mellon, and she and Yannicka, who is a professor at San Jose State, we're trying to work on something in the springtime to do some Discover-E events with young people and hope to build that again. SVEC used to have a big Discover-E presence, lost it, and now we're trying to see what we can do to come back with more volunteers. What
is Discover-E?
Discover-E stands for Discover Engineering. It started in the United States. It's actually gotten bigger, I think. It used to be always at Engineers Week. Now they've kind of changed it. I think it's its own organization. There's multiple themes, but the idea is to work with young people to help them do some experiential activities to discover what engineering might be about and how they could have fun in it. And I know that I'll just speak from my own personal experience. I retired from engineering the first time, and then I worked with First Robotics and these young people. How do we get more young women? That's my goal, and young people of color into engineering and computer science. So I went back to work and then went off and did a PhD in education, where I studied the influence of these kind of programs, experiential mentor-based programs, those have on career aspirations of young people, in particular, young women and young people of color. And those programs have a significant influence on when young people decide that that career is for them. And the key times are in that 4th grade to 8th grade timeframe. High school is just a little bit too late. It might solidify if you provide it. And before 4th, they're kind of really exploring a lot. But that 4th to 8th is when, in particular, young people of color, young women start to say, oh, society is telling me that's not good for me, maybe not as a career. And that's the time we want to say, wow, no, this is really exciting. You could have a lot of fun. So these experiential activities, fingertip knowledge, that would really make a difference. Okay. Did you have anything? Okay. All right. So we wanted to thank the event food sponsor, ASME. We appreciate their support. Thank you very much. And I've got a couple of slides, and I think Elise is going to talk to those.
Here,
go ahead.
she asked me to
go ahead.
About them. ASME, the American Society of Mechanical Engineers, which actually doesn't just cover the Bay Area anymore, because we have there was a all of like Northern California and beyond now is covered by the Santa Clara Valley section because there was a sort of a dearth of leadership. So we stepped in to lead a larger group now. But most of the events are still in the Bay Area. You can go to the and the website link.
That's a link tree. Linktree.ee
Yeah.
/ASME dot Santa Clara Valley section, I assume.
Yeah, I mostly I follow them on Eventbrite and it reminds me when they have events. But yeah, you can go to the next page. The events they have coming up are they're doing a holiday party at Buca de Beppo December 15th. They do a monthly Thirsty Third Thursday, which is a happy hour event.
It's a nature walk. There's a nature walk on at the Baylands.
Nature walk with dogs.
Okay.
We'll see if that happens.
And then there's
they haven't had one yet.
Tech Talk and Lab Tour that was November 7th.
Yeah.
And then tour at Whisk and Mountain View, etc. Future
joint
and past.
event with the electric vehicle.
Future and past. Okay.
Anyway, it doesn't say a date, right?
Right.
Okay. So anyway, the local American Society of Mechanical Engineers, they're a lot of fun. So you might want to look up their website there to see what events or follow them on Eventbrite.
Okay. All right. And the other sponsor we have who is streaming as we speak is ACM. We appreciate their continued they did this for the engineering banquet in February, and we appreciate their support with respect to that. Okay. Thank you very much. Now I'm going to give it to Yannicka.
Just a couple words.
Go ahead and use the microphone over here.
Sure. Hi, everybody. My name is Yannicka Schneider. So I am the president of the Society of Plastics Engineers, the Golden Gate section. And I've been part of a SVEC now for like 3-4 years. And so I lead the education committee. I'm very dedicated to education. And every year that we've been doing the banquet, since I've joined, we've kind of increased what we're doing. So we started out with just high school scholarship, high school and college. First high school, then we did high school and college. Now we're opening also to the master's students, so graduate students. So if you know anybody who is any of those things, high school, college, or master's students, we have scholarships, $500 for high school. Well, we have.
Anybody would like it.
Yes, we also need sponsors, but we will always do a certain number. We haven't committed to a number, but we have scholarships. The applications are open, available. They shouldn't take very long. We need judges. I think we have about 8 judges who have signed up. So if you're interested in judging the scholarships, we have a scholarship or application form for that. That might be on the next slide.
I think the mouse is for some reason.
Okay. There you go. So that's the judge form. This is the Keeper of the Flame. So Keeper of the Flame is for teachers, K through high school teachers who are really dedicated and passionate about science and engineering. So please, if you're interested in being involved in this, we meet once a month, and we're trying to be even more engaged with the students. So if you have any interest in that, you can email us at educationawards at SVEC, and it's on our website. So just go to SVEC-CA into the education and goes directly to me. So I will get in touch with, if for some reason I didn't get in touch with you before, just email me there. I check that email address. It goes right into my personal email. So I will get back to you right away. Thank you so much. One more slide. Right. It's okay.
Just scroll.
Okay. So Discovery, we are trying to get this going. This is one of the things that we haven't done in the last couple of years since we've ramped up again. So if you're interested in helping, for example, if you're an engineer and you want to come to high school and talk about your career or do an activity with students, let us know. We're trying to put together a database of interested engineers and also interested educators so we can do this matchmaking. Okay.
And that's her address, right?
And that's the address for,
There's
there's,
the words, right?
I think it's, yeah.
Okay. All right, and thank you for your support. And now we're going to transition. Oh, no, one more thing. We're going to transition to, let's see, hang on. So KRS.
Okay. I'm
Okay.
a professor at San Jose State. I've been there for about 5 years, but my main job is I'm a senior scientist and project manager at EAG Laboratories. Evans, you might have known about it, so that's where I work.
Okay. Come on up, KRS. He's going to introduce, and then we'll have to take a short 1-minute break to transfer computers for the speaker and hook up correctly on the live stream. He'll have to connect again. Okay. All right.
I'm Dr. KRS Murthy. I've been on the board of SVEC. I've been president, vice president, different roles. Back now as the on the board of directors. Today, it's my privilege to get a chance to not only invite Dr. Sunil Chaya, who is an expert in the topic. You will know in a few minutes only. And then he is going to talk about his specialty is low carbon mobility in EPRI, the Electric Power Research Institute. You are all familiar in Palo Alto. And he's a globally recognized leader in clean energy, grid modernization, and advanced transportation systems. And he has over 30 years, he looks very young, but he has 30 years of pioneering contributions to sustainable technology innovation. He has worked with NIST. He has worked in automotive companies as well. It's, how do I scroll down?
I'll just use the scroll.
Yes,
The best.
yeah.
Okay.
And then his PhD work itself started with AI. And he has done a lot of work with the NIST standards called IR 8473. You can look at it or ask him questions on that. The vehicle to grid platform company, such as Chargescape LLC, is a collaborative venture between Ford, BMW, Honda, and Nissan that deploys V2G, vehicle to grid. That's the abbreviation, capabilities at scale for commercial deployment. And he has worked with General Motors. That way.
Scroll button. There you go.
Got it. And worked with General Motors, and his contributions in technology aspects of EV and hybrid powertrain systems, and advanced EV powertrain system and software engineering work. And he has worked in PwC, etc., etc. So we are all looking to hear the expert speak on the topic.
Dr. Murthy, thank you very much for inviting me and for that very kind introduction. I hope to live up to the hype. Okay, any questions? Go ahead.
Just trying to quiet everybody down.
Oh, yeah. It's a town near Porbandar. I don't know if you know Porbandar, but it's the birthplace of Gandhi. It's a little town village where it's very common, I think, even in other parts of the country as well, to take the last name of the town that you originated from. Well, that's correct. So in this case, it just happens to be the name of it.
I think if you click on the 3 dots on the right, you can get rid of the top menu.
Let's see.
If you go down where it says hide floating controls right there. It automatically hides. Where it says hide meeting controls.
Hide floating meeting
Keep
controls.
doing it down one more. There you go.
Yeah.
It's only when you need to. So I'm not going to go into all this because you already gave a generous introduction. Plus, we are behind schedule here. So let me see if I can move the slides here. So myself, I want to introduce you to EPRI in case you are not all familiar with Electric Power Research Institute. It was founded in 1972 by one of the alumni of, is it better if I get closer? Okay. It was founded by one of the alumni of the Manhattan Project, Dr. Chansey Star, and it was set up in the Stanford Research Park. So that's where our headquarters still are. focused on, it's a 501c3, so not for profit, public interest, research, development, and demonstration organization working with the electric power sector. So our primary client is a global power sector. We work across all sectors, product generation, transmission, distribution, including nuclear, fossil, renewables, and then end use. So I've worked, many years on the electric vehicle side. So organizationally at EPRI, I'm in the end use part. How do you stimulate demand, right? Or in this case, herd the demand cats essentially to be more like supply. So collaboration is one. We work a lot with the stakeholders in the production, the providers, electric grid, and the science and technology community to create solutions that are generally facing for societal good. That's the idea. Lower cost electricity, more reliable and more renewable. So greener, reliable, lower cost. Credibility, independent. So, sometimes we come up with research results that the sponsors do not like, and too bad, we are public facing. We'll tell it like it is. So that's what we are valued for. And expertise. So EPRI does hire a lot of early career students, but there is a lot of experienced staff that they bring from multiple vertical research areas. And if you have interacted with some of our colleagues, then you would know the caliber. And so that's the thing. So I had spent some time on the automotive industry side. They had a need for extending the collaboration with the automotive sector when the electric vehicles became prominent. So they brought me on board, and I've been at EPRI for the last 17 years, hoping to have done justice to that. And we are global, roughly $500 million, approaching $500 million. About 1,200 staff total. I would say about 800 or 900 is, technical staff. The balance would be the administrative. 3 offices: Palo Alto, Knoxville, and Charlotte, North Carolina. Multiple labs, high voltage lab in outside of Boston, and some other offices, and also global. So, and the other thing is that we do quite a bit of work on strategic areas that we feel are of importance right now. Low carbon resources, so decarbonization and greening is very important. So heavy emphasis on hydrogen and low carbon fuels for all uses, all sectors. And use carbon reduction, looking at climate related investments, and also electric system flexibility. How do you make the grid behave consistently with the supply, which is intermittent and more renewable, so more variable supply. And then education around regulation and policy. We don't get into advocacy. It's against our charter, but we do provide research and development technical basis to make the decisions around policy. I'm going to try this. Okay. All right. So the outline of what I'm going to talk about is, so I was approached by Dr. Murthy. So I said, well, what should we talk about that will be of the topical interest today to the community? We can talk about a number of things, but you would not, maybe except for some ASME members, you wouldn't want to know about combined cycle turbines, something like that, gas generation, right? But so I said, let's talk about something that's of broad interest. So artificial intelligence, as Dr. Murthy mentioned, I've been associated with that for a very long time, close to, since my PhD days. So of course the technology ebbs and flows, right? So it kind of went into hibernation, but then we were just looking at what that might look like. So we started looking at the applications of this, and we found that there is quite a bit of stuff we can do right now. So given that I spent early part of my career looking at distributed computing. If you look at the vehicles today, right, they are basically computers on wheels for one thing, but they are real-time distributed control systems, software and control systems. But, very millisecond level decisions that are made, and they are made in clusters of controllers that are talking to each other. And then minimum, there are a number of data buses around the vehicle that carry around information that is just relevant to the other parts of the vehicle. So that is what I had done over quite some time. So I thought that will be a good way to think about how do you, now with the autonomous vehicles, we are seeing quite a bit of that. On-vehicle electronics architectures are also evolving to, going from multiple controllers to less zonal controllers, that sort of thing. But the principles is the same. You want to keep the information that is being processed as close to the data sources as possible, so that you can make very quick, low latency decision making, and have just enough information flowing between the relevant controller and electronics. So that's the idea. So today also all the training for the autonomous vehicles may be happening in the cloud, but the inference is happening on the vehicle. That's right there, distribution, AI at the edge, right? Right. Well, hopefully not over the edge, but yeah. So that's kind of where we live at the edge. And then autonomous grid. So about 6 years ago, I wrote a concept paper, and this is what I want to talk about. That's where I got the idea from as to where to go. But my idea was, and if you think about R&D, right, we are basically not too different from, I would say, science fiction writers, until we start, and I'm sure all of you can relate until you work on it and that fiction becomes reality, right? Yeah. Elon flying rockets or autonomous cars or robots and all that, they were used to be, Asimov, right? Robot used to be fiction, not anymore. So the idea was that we have a lot of information available at pretty much every level of if you look at the energy hierarchy, from generation all the way to the customer that uses the electricity, there is processing power available, there is communications available, and there's lots of data available. So how do you hierarchically organize that system so that you get the most out of the information that customer has to create closed loops around energy supply and energy demand, so that you minimize the burden on the grid to make all the decisions top down. The grid has been designed so that there is a major generation source and there is a customer. You flip a switch and the electrons flow, and that's pretty much the way it has been. Except that over time, it has evolved into customers putting solar on their rooftops, and now electricity is flowing in both directions. It can be going to the customer's home, but going back to the grid. So, that's a problem for, if too much of it is flowing right now, ISO, if you see the profile, you're almost going below zero. So you have a problem. Where do you put all those electrons? It's not like you have a lot of storage. So if you can consume that energy as close to the source, you are in a good shape, because now you have green electricity that doesn't need to be managed. It is managed, self-managed. So that's kind of the idea. But how do you do it so that you can react to those types of information in real time in milliseconds and seconds versus, minutes and hours? That is the idea. So that was the autonomous grid concept, to see how you can make it automated with the help of AI. That was the idea, to run inference. And it's amazing, the rate at which the computing power is becoming cheaper and cheaper. It's faster and faster, and the communications capability also, meaning data, the bandwidth, the price per kilobit or the price per flop, teraflop, whatever you want to call that, it's declining radically. So you have lots of computing power and communications bandwidth available in your hands. What can you do with it? And then the second part is, now that you have autonomous vehicles and autonomous grid, how do you combine them and operate them together as a system, energy system? Vehicles can be, electric vehicles especially, can be energy consumer at some time, but it could also be energy provider at some other time, if you can send the energy back to the grid. So that was kind of the idea. So as I was saying, there is, I would say right now we are kind of living in the, we have a problem of plenty, really, is that we've got, huge amount of hardware. And pretty much everybody's smartphones today have either neural processor today, or they will have it, pretty soon. I think every one of them has the capability to do that. AI PCs are just around the corner, right? I mean, we are hearing about it. So they're going to be the frameworks, pretty much, look at very lightweight, or depending on how complex you want to get, right? You can get them running on your smartphone. Today you can do that. So you can do inference very, very inexpensively and very, very ubiquitously. Communication technologies, they are always connected, always on, and mostly the bandwidth is idle, believe it or not. There's a huge amount of bandwidth that's available for doing some of these things. And so it is not too, I would say it is not too much of a stretch to imagine that, more and more computing capabilities will be pushed down to the edge, because you have lots of information that can be processed right near where the information is available. The other thing that it allows you to do is real-time processing, I was saying, so you can make decisions near zero latency, and that can impact the operation of the system in real time, so that you get the maximum benefit out of these systems. And then mobility and energy, of course, both of the systems are getting intelligent, that have communications and capability. So what I've been working on the last 17 years is to see how we can start working them together. looking at them as an integrated energy system. So that's kind of the idea. So that's the distributed edge AI. So hardware, as I mentioned, the frameworks and communication technologies, right? So that is where we are going, you know. So so if you look at just on the vehicle side, you know, in isolation, right, the autonomous vehicles, they are looking at you know, where is the value of edge AI, right? As I mentioned, low latency, high safety critical decisions made on the vehicles itself, you know, so they don't have to go ask a question to the cloud to make certain decision. As you see an obstacle or as you see some anomaly on the road, as the vehicle can make a decision by itself for passenger safety, for the vehicle safety, for just general traffic safety. The second part, you know, has always been a research topic, which is the intelligent transportation systems, you know, where vehicles talk to the transponders by the freeway and have the vehicle to X. And in this case, vehicle to everything is vehicle to vehicle or vehicle to infrastructure or infrastructure to and so forth, right? So have very high frequency or low latency communications happening as the vehicles are moving down the freeway to be more intelligent around the surrounding, the environment, and the transportation systems can be adapted with the traffic flow, with the weather patterns, with the driver behavior, etc. And you can create the system that reduces congestion on the freeways, reduces accidents, and makes the overall driving safer and less pollution. If you can divert the traffic to a place where it's not congested, then less pollution as well. So I think that those are the things that can be done when the decision making is happening right on the vehicles versus in the cloud. So perception and object detection, right? So that is one thing which is right in front of the vehicle. The lidar is detecting the things around it, and then making the traffic signs, the pedestrian traffic, road conditions, whatever that happens to be, the markings, etc., to make a decision in real time. Smart traffic systems, as I mentioned, and then fleet management. So fleets are basically just operational optimization opportunities, right? So they want to make sure that the inventory goes from point A to point B in the least amount of time with the least amount of pollution and least amount of least cost. So they are very interested in figuring out how to automate that and how to automate the decision making. In addition to even involving autonomous vehicles and autonomous freight, you know, there's a big topic right now in the fleet segment as well. So that can improve, reduce the cost of delivery and reliability as well. So those are kind of the use cases that they're looking at. And then what are the technologies? As I mentioned, perception systems, including the sensors, cameras, LiDAR, and other types of technologies that are already on vehicles. High performance computing, both on the vehicles and in the cloud, right, for training and inference. And then automotive operating systems that are evolving along with the capability on vehicle processing capability and also necessary communications upstream to the OEM's cloud or a third-party cloud, doesn't matter. But you know, those things need to also be robust and cyber secure at the same time. So in general, you know, it's always and with you know, great power comes this great responsibility, right? So it's one of those things where there are always trade-offs involved, right? So although it reduces reliance and cost, it adds cost to the vehicle. You know, these things are still very expensive. So that's the one thing we need to do. It increases safety, but then the validation requirement for vehicles goes higher because we need to make sure that if it's designed to be safe, then it has to be proven to be safe. A big discussion right now with the autonomous vehicles, you know, the self-driving vehicles or autopilot, you know, it's something still a regulatory hurdle for them to become widely available. Robotaxis, for example. Edge computing, the hardware constraints could limit, you know, so it depending on how much throughput and bandwidth you put on the vehicle, you know, that limits the application you can run on the processor. So it is still an evolving space, which is a great thing if we are researchers and scientists, right? So it's always interesting for us. So my role always has been to see what can we do with the technology we have today to see opportunities and also possibilities in the future. So and then federated learning, you know, so how do you distribute the learning part itself, you know, among the distributed nodes that are out there, and then bring the insights back to the mothership, etc. So maybe the cars have some way, or the sensors and processing across distributed processing has the capability to learn as well, not just inference, but even training to some extent. So there are a lot of possibilities with these types of systems that are as power processing power and bandwidth become cheaper and more widely available, it's only going to accelerate. And so when we start looking at autonomous grids, how can we apply the same principles and same technologies and same frameworks on the grid side, right? So edge, I was just thinking about, what are the types of data sources that are available today in the context of the grid, right? So you have the immense amount of customer data, whether it is rooftop solar, whether it is smart homes or smart buildings or smart, any other industrial customers, or whether it is the sensors around the grid, on the front of the meter side. So whether it is substations or field area networks or synchrophasers, there is immense amount of information that is out there, through the distribution and transmission system. And I was just looking, we have a project going on EPRI, for example, about smart substations. How do you automate the SCADA operation at the substation? Supervisory control and data acquisition systems, how do you automate all of those operations so that it becomes remote manageable? You don't have to go to the substation to manage to figure out, the age of the insulators and the gas composition of the transformer fluid, cooling oil, etc. Those are safety things, right? So a lot of these issues related to future, I would say, they are sort of the variables that show aging for one thing, but also if we can do maintenance in real time, then or you can also do prognostics on the system where you can say, all right, we are ready to run a round of maintenance. Although it wasn't a scheduled maintenance, there is something coming up so that you get ahead of the problem and have less of the disruptions, power delivery disruptions. So these are the things that they are looking at. There you go. So I don't know how many disruptions I have with Siri wanted to chime in on everything that I'm doing always. So we have a constant argument going on with the natural language processor. So there's the other part is decentralized. I was mentioning decentralized power management for renewables. So if you have consumption and production closely tied, then it makes it easier for more solar or renewables to be absorbed by the grid and remove the carbon from the carbon intense, make the grid less carbon intense. So that is where if you can match the consumption in real time with the production, you don't even need storage to be serving as a buffer. So as I was mentioning, fault detection, some of the use cases, fault detection, rapid recovery. How do you, and so some of them are looking at this, how do you, and then get ahead of the fault, prognostics, microgrid management, right? So when you are isolated from the grid, how do you operate that cluster of loads and supply and demand together so that, when the power is restored, it is an orderly transition back to energized system, and it just operates seamlessly and autonomously. And then renewable energy integration, a big topic, because renewable energy is not always, it is predictable in average, but not predictable in real time. So anyway, this was the paper that I was writing about 6 years ago, where I said, look, we've got lots of data available at the asset level on the left-hand side, buildings and sensors on the grid, etc., etc. Well, what can we put some AI close to where the data is so that we don't have to burden the upstream systems with all the processing, and the real-time processing allows us to do some clever things that are otherwise not possible, versus having a top-down. So anyway, so you can do behind the meter services at the local the house or household or building level, or you can distribution services like load forecasting or volt-var support, or curtailment for renewable support, whatever it is, or you can go all the way down to market participation at the ISO RTO level, so diagnostic, prognostic, dispatch routing, real-time dispatch routing decisions. And on the other side, we can think about it the same way in market terms. If we can glean somehow the customer references and customer demand versus customer supply and predictively predict the demand, we can then adjust the supply to create clusters of demand, supply, and market relationships between the providers and consumers of energy. So a local building has surplus energy available, for example, solar or rooftop energy available because it's a Sunday. They should be able to supply to the neighborhood customers through some kind of a transaction mechanism where they just buy from the local supplier. The grid doesn't have to worry about it. Now we created a market for them. So that was kind of the idea, peer-to-peer energy trading. So of course, ARPA didn't like our idea so we said that's fine. But the idea is that right now the utility model to deal with these types of things are reactive, upgrade followed by mitigation, followed by curtailment. So they upgrade the system or mitigation or mitigate the damage or curtailment. And if you can't do anything, they have public safety power shutoffs. Tomorrow between 12 and 4, no power for you, that sort of thing. In addition to that, there is the power procurement cycle, so the power planning, procurement planning is, day ahead, month ahead, or could be years ahead, depending on what type of resource you're looking at. Dispatch order is, in ascending cost, cheapest the class gets dispatched sooner and then all that. And distribution operations, again, planning implementation is annualized, figure out, which transformers need to be upgraded and what deep feeders need to be rewired and so on and so forth, right? They do that. All the electricity things, right? The power things. And the consumer management, right? So it is essentially how do you react to change in customer preferences, customer electrification, and customer loads, more electric vehicles, let's wait until something breaks and then fix it. That's kind of the idea. Well, over here, we can do this. Sorry. My favorite couple of slides, then we'll go fast. So we can get several orders of magnitude acceleration clock rates, months to days to minutes to seconds. If you have the information in your hand and there is information processing that can be done right close to where the information is, then you don't need to go up, you don't need to involve a huge organization to make those decisions. And when you make little decisions in time and fast enough, then they prevent a lot of big decisions of outages or disruptions down the road. So that's kind of the idea. So it could have capabilities like instantaneous sensing, followed by expanding the amount of load that the distribution system can hold at any given point in time, because it has a better sense of what is available in terms of capacity versus the load that's going to be out there. The interconnection capacity assessment. So that is about if you have a brand new load, let's say electric vehicle charging plaza that needs to be connected to distribution grid for PG&E, they need to go through 2 years of study, and then 2-3 years later, they'll say, yeah, maybe we can do it, but it'll cost you $5 million, that sort of thing. But you don't get any answer right away. In this case, the system that has the information in real time, they will say, we can make this work, most part of the day, and the cost will be this much, and it doesn't cost you that much money, etc. Now you have to take make some compromise. You can't charge anytime you want, you can't do some of the things, but it helps you utilize the existing capacity better. So the entire thing around the whole flexibility thing around grid is if you look at the US grid, it's the top 1% of the capacity, I would say, top 1% of the load, top 10% of the capacity is dedicated to top 1% of the load. So 99th percentile to 100th percentile costs 10% of the total capacity. So US grid is about 1300 gigawatts, 130 gigawatts, which is, a lot of gigawatts, right? Is dedicated to just meeting the last 1% of the demand. And this is not unusual about any system that we create. There's the curve about inventory versus service level, right? When you get to service level of like near unity, you have to carry huge inventory, and that's really what it is. Now, how can we use this? So effectively, the load factor for US grid is about 55, 52, and it's coming down. So what is happening is that you have to have twice as much capacity, this transmission distribution capacity to serve the average load. So if there's plenty of headroom, in other words, from the grid to absorb more electric vehicles, more electric homes, more electric everything. It's just that they need to be managed, and this is what allows it to manage it. So that was kind of the idea. So supporting the grids, so as I mentioned, distributed sensing and distributed computing, right? So and AI on top of that, it already exists. The distributed sensing already exists for a variety of reasons. So the data exists. The processing power also exists. What is not there are the frameworks designed dedicated for the grid to take advantage of this. Now there are a lot of startups in this area also, in Bay Area itself, that are working on this, but it is a fragmented effort. So what we are trying to do at EPRI is to see how we can start bringing these things together in a collaborative way, so that first of all, everybody has the same access to information, and create use cases that we feel we have juried across the user base, right? So that when they develop something or build something, there is value to it. So that's what we are working on. So the benefits are improved reliability, right? So if you can predict problems and avoid them, then of course reliability will go up, right? Reduce operational costs, again, same thing. Not breaking things up, so it's going to be better. And if you're proactive about it, then a stitch in time, right, saves time, that sort of thing. IoT enabled predictive maintenance. So I was talking about, if you can have sensors that are connected and processed, the data is processed, then you can get a sense of the aging of the infrastructure, the problems that are evolving and developing in the infrastructure, etc. And then smart inverters that are everywhere. In every place you see solar panels, right? They are smart inverters. So you can get a good sense of the real-time production of energy, renewable energy, that can be used to convert it to demand and supply equations to manage the load side of it, the demand side of it. And then, of course, the work that I did over a number of years around how do you start using the vehicles or electric vehicles as the mobile energy sources, right? So every Tesla vehicle, for example, 60, 70, up to 100 kilowatt hours of battery it carries, which can power average home for about 10 days, So in an outage, covering energy for about 3-4 hours, so 4 hours, so probably a couple of days, is a no-brainer if you have the right equipment available and powered, and it's cost effective, right? So you've been working on that. And in addition to that, sometimes when you combine, the individually 100 kilowatt hours may not seem like a lot, but when you have California has probably at this point probably more than 3 million vehicles. 3 million times, it's a 300, basically 300 gigawatt hours of energy. It's a very large number. My math may be off by one, but at least 30 gigawatt hours of energy. That's huge. California installs energy storage about 4 or 5 or 10 gigawatt hours at the moment. Don't quote me on that, but it's in that range. So you have a tremendous latent resource that's available that can, even if a fraction of it is available, you can do quite a bit. So that's why Patty Poppy, right, the CEO of PG&E and company, they are very excited about how do you bring these into the system in an orderly way. So that's what we have been working on. How do you scale this? How do you make them available to the energy, the owner himself, for their house or customer or business? And then how do you make it useful for the grid, and so grid. And similarly for AI, for all of these demand management, the general category of demand management, how do you, now electric vehicles, the best part of electric vehicles is that the energy consumption versus, meaning drawing energy from the grid, and energy utilization when they are driving is inherently. Oh, I'm sorry. Okay, so let me get back here. For electric vehicles are cool because the consumption and utilization of energy, consumption from the grid and utilization while driving, they are necessarily decoupled, right? You cannot charge and drive at the same time. So what that means is that when they're plugged in, the energy that they draw from the grid can be moved around. Around in terms of time. So you can shift it around when the grid is available and empty or low capacity. Go ahead.
I'm charging my electric car overnight, and you take power out of my battery. If I don't have enough power to drive the next day, that's not good.
So generally in the night, it's unlikely that the grid will need power because it's just basically idling. So that's one thing. It can happen in daytime, but absolutely. Yeah. So generally these things are done cooperatively. So you will set, for example, what you think is you are willing to trade. There has to be some kind of an incentive on the way back, in return for X, right? Energy in return for X. But you can completely opt out. So it's not something that you suddenly find your car to be empty or, oh my God, I can't get home, stranded. So, yes.
What do you think of cases where there's a disruptive technology where the grid is no longer the key aspect of how people deal with power?
Might want to repeat the books.
So disruptive technology where grid is no longer the determinant for
Distributing power. I mean, right now, I might get power that generated out of state sometimes.
yes.
It's the idea of putting on an always on grid, which was an engineering marvel in the 1930s, might not make as much difference if people say we can get by well enough and not have long haul electrical grids or not have a statewide power system or relegate the grid to a trickle charge for when we would like to slowly trickle charge things up, but it does not have to be gigawatt connectivity.
So there is a lot of work. I'll get to, you were saying something when I get to that, but the thing was, what if you can create essentially self-sufficient or energy self-sufficient clusters of energy so that you're transmitting less and less energy over long distances. So if you can meet your demand locally, then you have self-sufficient clusters. There is research going on, they call it the resilient distribution systems, where you inherently design the supply of energy along with the very close to the demand, where demand is. So create logical segments of distribution systems where in case of an outage, there are additional advantage to that. In case of an outage or a natural disaster, the healthy segments of the grid can continue operating if they have demand and supply both met locally. They can isolate from the mother grid and they can still remain operation. So that's very much on the cards. And I think that it is going to happen more and more. When you see solar and storage, I don't know if you saw this massive charging installation that Tesla is putting together along I-5. They said 68 gigawatt hours of storage. They mentioned 7 or 8 megawatts of, it's a megawatt hours, 68 megawatt hours. It's a massive installation for charging infrastructure that is almost isolated from the grid. It is self-sustaining. Solar storage, electric vehicle charging, island, 100%. So we have always believed that grid defection, as we call it in the industry, where the folks who can afford to have their own energy supplied locally, they will just disconnect from the grid, cut the cord, done. When you aggregate that across communities, that can happen even faster, because now you can think about law of averaging and you have enough resources nearby. With solar power, as we were talking earlier, with solar cost of kilowatt hours and the storage becoming cheaper and cheaper, it's very much a likelihood. The other thing is data centers. We didn't want to get into that because that's a topic by itself. They are creating a demand for distributed generation across the country, and when you have these resources available, imagine what you can do locally for doing that. So yes, distributed generation is very much. What was the other question? Thank you. Yeah, we are about, I would say, pretty much close to them. Okay, so let me see where we were. So there are companies working on how do you aggregate, that's the challenge, how do you, it looks great, in isolation, one vehicle, one home, and it does the job great. Okay, take 5 vehicles or 20 vehicles or 2,000 vehicles. Now you try to support grid, now you start looking at how do you balance all of those needs, exactly what you were saying. I need to get up to drive my vehicle to work, and then I need to come home, and I don't want any disruptions. I want to have some predictability in this thing. You can't have random things happening in the car when you're plugged in. So how do you manage that customer-centric way to do this, because otherwise, nobody will sign up for this kind of stuff. So that's what they're working on, companies like that. It's not an easy problem to solve, which it makes our researchers' jobs fun, they're working on figuring that out. Battery management system. So the other part is the customer is one where the owner of the EV is at the apex, the top of the food chain, where you decide how your vehicle behaves while driving, by charging. The next thing is the battery decides how it wants to be charged and when the energy is used. So that's the second part, because battery needs to last the life of the vehicle. So that's the second constraint. The third is everything after that is, whatever you can get, the icing on the cake. So those two are minimum constraints that we have to manage. So that's what they're working on. And then real-time energy trading they're talking about, which is, how do you create these packets of energy that can be traded across time and space, essentially. So again, seamless connectivity, and how do you take some of the algorithms and frameworks that exist on the AI side to make some of these nonlinear stochastic systems, and make them behave. We understand that how these things are supposed to work behaviorally or in general. So we can predict, generally a person's daily routine, if they are working, they have a certain kind of routine, but we can't predict exactly what time they are likely to be where. So what AI is trying to do is to make sense of all these and maybe segment the customer so they can maximize the use of that opportunity for a specific use case. I mean, that's really the whole name of the game. So, but it doesn't come, it comes at a price, data privacy and security. We spent quite some time. I think you mentioned IR 8473, that is the cybersecurity protocol for framework for electric vehicle infrastructure. How do you secure the infrastructure in the grid for electric vehicle charging, etc. So privacy and security are very important. Personal data, location, PII, right? Personal identifiable information, and so forth. How do you prevent hackers to do bad things to the grid, to the vehicles, to other assets that are connected to the grid? And also resource constraints, right? No matter, it's always I always see like the computing is a race between hardware and software, right? By the time we have the computer working, it starts to slow down because now the operating system and all the junk that's has caught up. So it's time to upgrade, but once you got it all down, it's time to upgrade. So it's always a race between, hardware and software. I don't think we have gained anything in terms of functionality since Windows 95, but, hey. You still boot it and do the basic things, for most part, there are specialized, they're different, but 95% of the people. And lack of standardization. So, you can't create vertical integration, the standard stuff, right? Motherhood and apple pie. Can't create vertically integrated systems. They break down. Companies go out of business, stranded assets, bad things happen. So, standardization. So we spend a lot of time on standardizing the interfaces, the communications, the data exchange, the data models, etc., and then transfer the know-how to the car companies, to the grid companies, and to manufacturers, etc. So that, and then do the validation and interoperability testing, that sort of thing. So, where is the future, right? So, you can't conclude an AI presentation without saying something about quantum, right? So that basically accelerates some of the AI data processing. And well, the problem is that you need to have the quantum computer in a specific state, so that it comes with its own set of challenges. But it is the out there thing, right? So we look at it, and then the richer data. So more data. There's always more data available, like exploding data. So we can always find new use cases, and then scalable modular edge architecture. So as the chip industry catches up and finds the new use cases that they want to invest in, they're going to be more and more powerful processing capabilities, communications capability, and embedded AI on the edge. That's going to be more and more ubiquitous and less expensive. So anyhow, that's basically the idea. So the big thing right now with EPRI is looking at powering the infrastructure, right? So every AI hyperscalers are looking at multi-100 megawatt installations for generating capabilities. How do you power these things, right? So as AI becomes more and more powerful, the training requires more and more energy. So that's what we are worried about. Scratching head thing. How do you support this? But and then energy efficient. So that's the other thing. The industry is also looking at how to make the inference training part more efficient, make more efficient process and so forth. And then security and distributed ledger type stuff. That's always in the background. So we always focus on collaboration. And this is not one person can solve all problems. So we believe in collaboration. Let's bring our collective expertise together, identify and at least speak the same language around defining the problem, so we can find solutions that help all industries that are an open innovation framework. So we do believe in that as well, to the extent that things can be open. We want to work in the open standards domain, open information exchange domain, etc., and enable the innovators and creators with the necessary information so they can be successful and be productive. So that's pretty much it. What I'm going to say, a couple of things, call to action. So we have a workshop coming up. If you are more interested in learning about AI and the power industry, there is a workshop we are sponsoring with Stanford Bits and Watts guys. I think it's in Palo Alto early next year. There's also a lot of work going around, so I will circulate the slides, but you'll be happy to talk to anybody.
Distributing the slides so that they can go.
Yes, exactly. So that's all I had. Yes, please. And yeah, so DC Flex is the way to use the data centers as a grid resource. So the idea is that can we do something? Can we use the data centers where with their immense, massive, awesome power capability to see if they can support the grid also during some times, So that's kind of the idea. How do you? Otherwise, you're going to just end up spending a lot of. And then there is a lot of. If you go to epri.com and look at just type A artificial intelligence, a lot of the work that we do becomes available in public domain. So you can look at what is power sector, interest right now on the AI side. You can look at that with some detail before, and there may also be. And if you have any questions around power industry related AI, will reach out to me. I'll be happy to connect you with the right people.
Good presentation.
Thank you.
Next presentation, yours should be SMRs.
Okay, we will bring us. We will bring SMR guys over here and be happy to talk.
Questions? Yeah, any questions?
So you said the incentives for people to transfer power from the car or from home, right? My understanding is that it's decreasing, and the incentives are decreasing for putting on it. At least that's what I know where I live. Solar power which is being generated by the houses, which are the PGID grid. There were more incentives earlier, but then they're decreasing. Why is that so?
Net energy metering is the thing that the idea is that the incentive to send power back to the grid is reducing, monetary incentive, and that's a fact. And NEM 2.0, which was the prevailing protocol and which is for settlement, was it was I think you were being compensated at the prevailing rate. So let's say your tariff happens to be for consuming 35 cents a kilowatt hour. Then if you send energy back to the grid, you also get 35 cents a kilowatt hour. Now it is net generation. The problem with the thing is that the grid doesn't know how to use all that energy that's going back. So they are saying that receiving energy back to the grid is more of a headache than. So that's why they are saying they are incentivizing the generators of the energy, residential, commercial, industrial, to be self-consuming. They say that is the best way. But for that, you need to have storage, local storage, which adds cost to it. So, the payback period for these systems used to be like 3 to 5 years. Now it is 20 years, 15 to 20 years. It is still, given the rate at which VG&E rates are going up, it is still a good deal, but it's not as good a deal as it before.
So please repeat the question when people ask questions.
Okay, no problem. Yes. Yeah, the question earlier was the declining incentives for sending power back to the grid, and how does the vehicle to grid feature into that? Go ahead in the back.
Several governments before this, the private sector, contract
In the future, the question is in the future, who controls all this? I assume you mean sending power back to the grid. I think that the utilities are, because it goes to the utilities grid, they are governed by their respective utilities commission. So California has California Public Utilities Commission, and different states have their own jurisdictions. So those are the governing authorities. So they set the rates, they allow what is allowed and what's not allowed, how it should be compensated, etc. They set the rate. So all these and NEM 2.0 and NEM 3.0, they are all, they are the regulations that are crafted, for example, California by California PUC. Go ahead.
Industrial demand is different from residential demand. So do you think the microgrids have to be separated out, supply demand curve for one side and different from the other?
So the question is the demand curve for different types of the segments of customers in residential, commercial, industrial are different. So how does the microgrid adapt to that, right? You have to design the system to work for the local. Microgrid by definition is supposed to serve the local load, the one that connects, within the defined parameters, right? How many days of isolated operation, what it's controlling, etc. So it is very customized, yes. Yes.
industry, you mentioned AI use more and more energy.
Yes.
Actually, there's a question of the scale law of the AI. So when the usage of the energy increase exponentially, does written what the merging value really makes sense? Because if the AI, the ability of the AI is not scale well, then you use a lot of energy, but you don't get much.
Yes, so there is a lot. Yes. The question is the diminishing returns of all the training that's going on. So, the more training you add, are you getting better fidelity results, right? That's the question. And there are two parts to it. One is that they are running out of data to train with. So that's depending on the domain, So there is a lot of head scratching, introspection, whatever you want to call that. But it's a fact. More does not always mean better. Or more, so you by 2x power or 2x capability does not give you 2x results. That's the thing. 2x better results. That is a fact. We are getting to a diminishing return. So that's very much true. So that is putting pressure. There was an article I just read a couple of weeks back saying there is more hype right now than reality in this space. So what they are looking to do is to create domain-specific AI so that they can show more near-term value to specific customers and industries. So it's becoming AI the general intelligence is fine, but it is the specific intelligence that is finding a lot of value with the businesses. It's trained based on business-specific data. Yes, go ahead.
So one of the three areas that you identified as the challenges, that is the open standard.
Yes.
So in order to address that, is the people in the industry, expert state, are they looking to like possible way to standardize that so that way they lay in a path for the integration a bit more easier for the growth of the technology?
The question is the role of open standards in facilitating growth of these technologies. We totally believe in that. Now, unless the company equals industry, right? Like Tesla used to be electric car industry for a while. They could afford to do that. Now they are saying, well, even we are not big enough to support the whole industry for charging infrastructure. So they made their connector, the charging connector, as an open standard. Everybody else sort of adopted it, and now it become like the industry standard. So I think that it may be okay for a company to think that they can go it alone and have a vertically integrated technology stack. It is a limited view. It's always a limited view. So you're right. So yes, so we always work on standard. Go ahead. No, I don't.
On the vehicle grid. Right?
Yes.
This is about vehicle grid is that it seems like, at least in this country, or maybe in other parts of the world, perhaps, it seems like something of a, what should I say, it's very elusive in terms of actually implementing it, because people have been talking about that since like 2010, as far back as I can remember. But in practice, its actual implementation has been very, very slow in terms of adoption. So that's one of my observations. The second part as to why it is, my theory is people, I personally find vehicle to grid to be not a great idea, because the current ternary type lithium ion batteries, these electric vehicles have relatively short lifespan compared to, let's say, LFP electric vehicles. So it shortens your lifespan. So isn't that a possible factor to why people like it? And third reason is, third thing we're talking on the, do you think that, as I say, the government, like federal government, has to take a greater role in implementing vehicle grid of vehicle X? Because it looks like there's one manufacturer that in the electric vehicles that doesn't like this. I won't say which one, it's something to keep. What's your comment on how it's what else?
So there were three threads there. One was, how come if vehicle to grid is so cool, how come it's not out there in scale, right? So that's one thing. The second thing was, what about the batteries, right? Will the batteries life of the vehicle and will the batteries get affected. And the third one is, vehicle to X, right? What's up with that? Or what are the policies, federal or state policies, maybe driving or affecting that? With the first V2G project I was involved in at EPRI was 2007. So I think you there. So there were no vehicles at the time, but then the vehicles came along and so forth. The industry has come a long way. Now we have been involved with standards implementation, and now even a lot of the work that we've been doing is around how helping automotive manufacturers with how to commercialize this on both sides. So working on the standards and so forth. Battery, we worked with NREL to look at the battery degradation. You can look up, I think there's a company that publishes the battery degradation data for all electric vehicles. And they are saying that Tesla also published something a couple of years ago that their batteries will last, they've talked about million mile batteries, so I think that the battery question is somewhat understood, but in any implementations involving non-mobility use of the vehicle batteries will have to be managed by the vehicle itself. So when the customer puts the constraint saying, no matter what, I always need to have 100 miles drivable range, you cannot touch that, so that's the first constraint. The batteries will say, hey, we can only take so many kilowatt hours over so many period of time, and I'm counting every one of them because my lifetime of megawatt hours is constant. If you take it out for non-mobility use now, then it's like a bank account, every time you use it, it's depleting. But right now we are seeing that for 10-year life, 15-year life, you should be okay, even with the last generation lithium ion. It's just improving always. But it is not it doesn't happen by accident because the OEMs, the car companies design the batteries to last a long time because it's a warranty issue. You have to replace the battery. The OEM gets hit with a warranty claim, so that they don't want that. So OEMs will decide the policies, the customer will put constraints, and the battery will have its own constraints. I am too hot right now, get lost. I'm not giving you a kilowatt, go away. So it will have a veto authority. So that's the second part. I think the third part was policies and regulations. I think that they are waiting and seeing as to how this develops. So right now, all the equipment that is out there for vehicle to grid is expensive. And it doesn't make sense. You are better off buying a power wallet, be done with it. If you really want, resiliency, outage protection, right? So vehicles are not quite, but that's not forever. We believe that the best systems are, and we are working on those right now with a number of OEMs, is to put this equipment on the vehicle itself. So if the charging station that is on the wall is no different in physical form and function except by software than what you currently have, level 2. And so when you put the equipment on the vehicle, it gets to the vehicle scale economy and you can get it very inexpensively. It just plugs into the wall, it's connected, recognized by the grid to send the power back or send the power to the home. And those systems will be out then. They have the most chance of success because when the equipment gets on the vehicle, then it is subject to the OEM's purchasing power. It is subject to the OEM's validation processes. It's subject to the robustness with which the vehicles are designed. Right now you put something on the wall, you don't know if it's going to last. It's flaky stuff. Those guys, they come in and put something on there. They may not be around next day. So, yeah.
So
Last one.
So fuel cells car, I think in the future, because 20 years back there was a lot of hype about that, and I've worked in that area, so I know. But right now, I don't see any. I mean, they were saying there's no hydrogen infrastructure. That's the reason. But you can. I mean, I'm sure everyone wants to look at it. And
that is the area I'm working on right now. So light duty is done. They'll deal with electric vehicles. Medium and heavy duty, there are use cases where it makes sense. But it is cost, access to infrastructure and the vehicle. It's a doom loop right now we are in. So we're trying to break that cycle.
So
Lower the cost of hydrogen.
So hang on just a second.
We can talk.
Yeah, we can talk afterwards. I was curious if there were any questions on the live stream.
Yes.
Anybody there? Okay, I guess not.
I don't see any questions.
I don't see any questions. Okay, so we planned we'd be at 8. I'm sure he'll stay and answer some more questions. So let's give him a round of applause for inspiring talk. Thank you very much. Appreciate it. And I bet you there's still some food. If you want it, feel free to take some. Feel free to stand up and ask more questions. And again, if you want to volunteer on any of our programs, please talk to any one of the board of directors. Thanks a lot. Okay, we're gonna close off the streaming, okay? Right?